Welcome to a video on sections 3.1 and 3.2. The title of these sections will be Solving Linear Systems of Equations Graphically and Algebraically. Just so you know, section 3.1 is graphically, section 3.2 is algebraically. But I feel like we can combine these two sections into one since they both deal with solving linear systems of equations. So let's start. Actually, we'll just do one example. But we'll do it three ways. So here we want to solve for x and y. And here are the two equations. 6x plus 2y equals 4. Negative 2x plus y equals negative 3. So this right here is considered a linear system of two equations. Linear because they're both going to be lines. If you get y by itself, you would see that they both follow the slope-intercept form. So they're both going to be lines. And then it's a system because you have more than one equation. And of course, we have two equations here. So there's going to be three methods we'll use. We're going to graph. We're going to use substitution. And we're going to use elimination. So there are three ways we'll do this. Let's try the graphing way first. So method 1, which will be a graph. So in this method, what you want to do is graph both lines. And locate the point of intersection. The point of intersection will be our answer. So if you look at 6x plus 2y equals 4, that should be easy to graph. You first want to get y by itself. So see how that's in slope-intercept form. And for the next equation, do likewise. And then we graph. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So negative 3 is right there up to over 1. We're going to plot, we're going to now connect those 2 points. Negative 3x plus 2, y-intercept's 2, down 3, over 1. And it should be pretty obvious. That should be our point of intersection right there. So we get 1 common negative 1. There's also a way we can do this in the calculator. And we'll talk about that when we meet again as a class, how you can use a calculator to graph both these lines and then to locate the point of intersection using the calculator. This is not a terribly accurate technique, so this is not really recommended, this method, but it's good to understand what's happening graphically. So when you solve a linear system of equations graphically, the point of intersection will represent the answer, because that's where both lines will share the same x and y coordinate. And so it satisfies both equations. So good to understand what's happening graphically. Okay, let's do method 2. Now this is the method I think most of you are familiar and comfortable with, and I am too. So we should be in agreement that substitution is going to be a good way to solve this problem. So substitution, what you want to do here is get one letter by itself for one of the equations. And substitute, that's a key word here, substitute into the other equation. So, again, our equations were 6x plus 2y equals 4, negative 2x plus y equals negative 3. So, how should we go about substitution? Which letter should we get by itself and from which equation? If you said y from the second equation, congratulations. It's easy to get y from the second equation by itself because the coefficient for y is just 1. So we won't have to deal with fractions. So let's get y by itself here. Yeah, because dealing with fractions is bad. So then we substitute into the first equation, replace y with 2x minus 3, and just work it out. 6x plus 4x minus 6 equals negative 3. 10x will equal 3. Okay, so I made a mistake somewhere because something's not working out quite right. So I'm trying to figure out what I did wrong. 2x minus 3. Ooh, I totally see what I did wrong. The reason why I know I'm getting the wrong answer is because I'm not getting the same thing I got before. I copied the problem wrong. Okay, that should have been a 4. So my apologies about that. So 6x plus 2y equals 4. We're replacing y with 2x minus 3. So x equals 1. Now, we can solve for y by plugging 1 in for x. You get negative 1. And you can plug 1 in for x really into any equation to solve for y. Just easier to plug back into y equals 2x minus 3. So, again, we get the same answer. And then the last method. Method 3, which involves elimination. I like this method too, depending on what we're dealing with. So for elimination, what you want to do is multiply one or both equations by an integer so that the coefficients of one of the variables is the same. So here we got 6x plus 2y equals 4. And negative 2x plus y equals negative 3. So there's a few ways you could do this. What I'm going to do, I'm going to multiply the second equation by 2. What's going to happen is that you're going to have negative 4x plus 2y equals negative 3. All of a sudden now, the y's from both equations will have the same coefficient. So if I work this out, 6x plus 2y equals 4. Negative 4x plus 2y equals negative 6. Now comes the elimination part. If I subtract the two equations from each other, there we go. Okay. Don't know why I want to disappear. Okay. If you subtract the two equations from each other, 6x minus negative 4x is 10x. 2y minus 2y, of course, is just nothing. 4 minus negative 6 is 10. So 10x equals 10, x equals 1. So you still get the same thing. And then you could substitute back into any equation to solve for y. So you plug back into the second equation. So y will equal negative 1. So we still get the same thing. So you have 3 techniques. Graphically, probably not recommended just because it's not terribly accurate. Substitution, I think, is what most of you are familiar with. It works just great. But also keep in mind that you can do elimination. And sometimes elimination will make more sense when we start doing with like multiple variables, or not multiple, obviously there are multiple variables here, but when you start doing 3 or more variables, sometimes elimination will make sense. Other times elimination is better if you know that substitution is going to result in fractions. That's another thing to keep in mind as well. So you learn these techniques. We're going to practice them next time we see each other. And that's it. We're all done. I'll see you later. Goodbye.